dissolved in HCl. Unknown 3 dissolved in sodium hydroxide, and it also dissolves in sodium bicarbonate. So you can record this observation and use the tables provided in the experiment, identify the functional group, and if needed or following the procedure, we do the classification test. Unknown 1, 4, 5, and 6 did not dissolve in any of the solvents so far, did not dissolve in water, HCl, sodium hydroxide, or sodium bicarbonate, which we didn't test for, and we should not have tested for. And now we are going to test with the concentrated sulfuric acid. If it reacts or dissolves, that means that it could be high molecular weight alcohol, it could be high molecular weight aldehyde, ketone, or unsaturated hydrocarbon. And if it doesn't dissolve, it doesn't react with sulfuric acid, it could be alkane, saturated hydrocarbon, alkane, or it could be aromatic compound. So we are going to use like 3 to 4 drops of the unknown 1, and unknown 1, 3 to 4 drops. Using the procedure, unknown 4, add about 4 drops of the unknown to 3 and 4. Unknown 5, tip of a spatula, 0.1 gram or tip of a spatula. Just adding a few crystals. You can see it, that's good enough. And unknown 6, we are adding 4 drops. Okay. Now, to each of the test tube, we are adding 40 drops or 2 milliliters. I think the technique that I showed you, or to approximate the milliliter, it's coming handy now because we are dealing with concentrated sulfuric acid. If you use the graduate cylinder, by the time you transfer to a test tube and you return it, you would have some leak of that concentrated sulfuric acid on the graduate cylinder. You touch it, then you touch your skin, you touch your face. So for safety and saving time, it's better to use this approximation as long as you keep the ratio of solvent to solvent the same and consistent and proper. You don't want to saturate your solution. So we are adding 2 full droppers of the sulfuric acid to unknown 1. This reaction, a color change, it can indicate a reaction here as well. Sometimes it's just the color change that would tell us, or formation of 1 layer. So we are going to add 2 milliliters to each of the test tubes of the concentrated sulfuric acid. Going to finish adding. Then I will check each of the test tubes for the results. Okay. So test tube 1, the color change, where you could see it better. There's a color change. It's not white color. How do I know it's not white color? And what should I do to see that there is a white color? I'm gonna get a test tube that has clear solution, no clear solution with, so you could see the color change better, okay? Just using this as an example. It's much better to always have a blank or you know, a reference test tube. But if you can't, right now, it should be much more clear that there is a color change. This is my compound 1, unknown 1 with the sulfuric acid. And for sulfuric acid, the color change indicates of a reaction. So there is a reaction for sulfuric acid and unknown 1. With unknown 4, also there is a reaction. I'm going to show you with the reference. This is the unknown 4, and that's just the reference. If there was no color change, that's unknown 4. So we have color change for unknown 4. Unknown 5, mix the unknown 5 with the sulfuric acid. It has not dissolved yet, no reaction yet. It's going to give some time to make sure. It's going to add a little bit more of the sulfuric acid. If either the solid disappears or if there is a color change that we could all see, then we record as a reaction. We're checking the unknown 5 one more time in H2SO4 after sitting for like 2 minutes. It did dissolve. Like before I discard, I checked again, it did dissolve. So unknown 5 also dissolved in sulfuric acid. Color change is a reaction. Disappearance of the solid compound that we had, it also indication that this compound is soluble in a concentrated sulfuric acid. There is a color change, but the color change is like a tannish or yellowish color. It's very hard to see it through the camera, and I hope you could see it, but there is no solid left, so it is soluble in the sulfuric acid. And unknown 6, there is a very obvious color change, and there is a reaction. So unknown 1, 4, 5, and 6 dissolved in sulfuric acid. So they must be high molecular weight, meaning that more than 5 carbon polar compound. It could be alcohol, it could be aldehyde ketone, or alkene unsaturated. Okay, we're done with the solubility test. Next step would be classification. We are going to test the remaining unknowns, which is unknown 1, 4, 5, and 6. These are the ones that dissolved in sulfuric acid, but did not dissolve in water, HCl, and sodium hydroxide. We're going to test with 2,4-dinitro, phenyl-atrazine. If a yellow precipitate forms, means that it's either aldehyde or ketone. And for this test, we are adding, again, 4 drops of the unknown. That's unknown 1, unknown 4, unknown 5 is solid, so I'm just going to add tip of a spatula of the unknown 5. We have unknown 5, just the tip of a spatula. And unknown 6, 4 drops. Adding 4 drops of each. Now, they need to be dissolved in 1 milliliter of ethanol. So I'm adding 1 full dropper of ethanol to each testing. With the ethanol, I added 1 full dropper of ethanol to each unknown. It's dissolved as a solution. And we are going to add the reagent of 2,4-dinitro, 1 milliliter of this reagent. If a precipitate forms, is aldehyde or ketone. If no precipitate forms, means that is not aldehyde or ketone. a yellow color solution, but since it's transparent, this color is coming from my reagent and is not a reaction, at least not yet. I can leave it for a few minutes and come back to it again, but no reaction for now. So unknown 1 has no reaction with the 2,4-dinitro. Unknown 4 with the 2,4-dinitro. Okay. Unknown 4 also showed no reaction for now. Yeah, for unknown 4, no reaction for now. So it's not aldehyde or ketone. Now, unknown 5, I have solid compound in ethanol, is almost dissolved. So I'm going to add 1 milliliter of the 2,4-dinitro and a formation of a precipitate means that is aldehyde or ketone. The precipitate is forming. It turned cloudy. And I hope that you could see. And if you don't see it right now, I'm going to take another test tube with no precipitate, just the reagent that count as a blank or reference, so you could see the difference. Okay, unknown 1 with no precipitate, unknown 5 cloudy with the precipitate. Okay, and this is clear or transparent. You can see the line behind it. This one, you can't see the line. So 5 form precipitate. So 5, it could be aldehyde or ketone. Unknown 6. Unknown 6, going to add a 4-dropper, which is 1 milliliter of the 2,4-dinitro. Also formed precipitate. This one is obvious. I don't think you even need the reference. It's obvious, but just to be consistent, I'm showing the reference for this one. Unknown 1, no precipitate. Unknown 6, a precipitate. So 2 of the compounds, 2 of the unknowns here form the precipitate, and that means that they are either aldehyde or ketone. The others, after waiting for this long, it didn't form precipitate. So at this point, I could say that they are not aldehyde or ketone. But to confirm this, we can heat up this solution in a, because it's unknown, we can heat it up in water, hot water, like between 60 and 70 degrees, or heat up in the hot water for like a few minutes for the precipitate to form. This reaction is very fast reaction. If you have aldehyde or ketone, it's going to form precipitate. And the color of the precipitate, you could go anywhere from light yellow color to like dark orange color, and depends on the aldehyde or ketone. I will keep this in the hot water, and I will show you when I'm doing the other experiment, just at the end of the reaction or this video, if it did form, and if it doesn't form, it doesn't form.